Yes. 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 Man, bro, that's so loud. Jesus. I said that's so loud. But no, it's all good. You do what you gotta do.
It's almost done, I promise.
Let's bring up the channel. Yes. 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 We are live. Yes. All right. Let's do this. Woo! Let's get it. Okay. So, we're coding in MATLAB, obviously. So, I don't know who's gonna be watching this. If you are, you're the homie. You're sick. Welcome to the nation. But yeah, we're building this tool right now that oh, I should share the stream. Let's share the stream. Show the people some love. Put it on the Facebook. All right. So, sort of in the final stages of this thing right now. So, this is the application. It's like this little studio, but basically what we made here is this like, so we have a compiler that can create EEG movies, basically. So I'll pull this up. I've got this like, I'm just looking for a file. Hold on. So we created a movie, and that movie that we created recently is called, oh, what was the last one that I made? Is it Real Test Movie? Oh, shoot. what do we call it? I made a final one. I don't want to have to recompile a new one. Well, I might as well, just for sanity checks. So the way we do that is you go up to the compiler up here in the application where it says compiler. I should put a link to the GitHub so that people can download it if they want. But I'm still working on it, so I wouldn't download it just yet. But you can pull it and criticize my code if you want. It's probably not great, but it gets the job done. So, okay, this is going to be the GitHub. I think people see it if I do it that way. So, I don't know. Either way, so we go up here to the compiler, and we select our data file, which, should I just like, should I go through the whole thing? Should I go through like how all of this is built? So your data file is going to look like this. This was just like some like epic data from an EEG set. And so this is what our data looks like. It's just, all it is just like these channels, and each channel has a time point, or each time point has 64 channels. So like this is a channel, this is a channel, this is a channel, this is a channel. So these are all channels. And then each column is a time point. So basically we compiled all of that into like a movie player. And that's what this compiler does up here. So all we're doing is we're taking this data file that has like these columns and rows, and we're compiling it into, so this is our example data. Let's open that. And then we're getting our chanlocks file, which I don't know how to explain what that is. It's basically like a map that tells us, that helps us plot our data into like an EEG graph. So actually, I guess I can like, I can plot some EEG data real quick and just like, so I just grabbed like one column of this data and called it X, and then load in our chanlocks, and then chanlocks is just, it's this like, it's this file. So I guess we can look at it, but I don't really know what's in here, to be honest. I just know that we need it in order to plot data on a topographical map. So it has like all this information about like FP1, FP2. These are all just the channel names. And then these are like coordinates, like where they are on your head, like on the heat map. So what we need to do is we need to use, this is an EEG lab function, which you need EEG lab in order to use the software. So if you don't know what EEG lab is, I should put a link to what EEG lab is. EEG lab, MATLAB. So you want to download it. This doesn't look right. What? Did they change their UI? I want to download it. Yeah, this is what you need. So I'm gonna dish a link to this if you want to download it. It's really cool. So there's this function called topo plot, and all it does is it takes in like a data matrix, which your column is your time point, and then your rows are your channel voltages. So just like this, exactly what we just extracted from this data set into X. So we toss in X and our chanlogs file, which we loaded in over here. So you dish that in, and then you get this plot. Where are we at? Okay. So this is what we get when we plot it. It's really easy to plot. And then what we want to do is we want to sort of filter this out, filter out the colors. So what we do next is we load in this other file called AGF color map. And then I think, well, it's just going to look slightly different. Forget how to do this. I think it's in the compiler. Hold on. Compile. How do you change, or how do you filter out? Okay, just color map, and then AGF map, which is what we just loaded in, and then cool. So it filtered out what we don't really care about, and so you can tell that there's like a little bit of what is this? A positive charge over here. These are negative deflections. And so we get like this sort of heat map of the brain at like a single time point. So what we want to do, if we go like this, if we extract the second frame, so now that is all the second frame, we can see that it's a little bit different. Actually, well, we needed to plot it on a new figure, and we needed to clear it first, but it's a slightly different image, and you can still see the contours from the first image. Like right here, like this contour right here is a contour from the first image, and then this like slightly wider contour is from the new image. So that they're actually on top of each other right now. But we want to do is we want to clear them out every single time and play it back as a movie. So we load in our files. Let's do this. We'll call this ZZZ. It's just like a test, and we'll compile it. It closes everything because the way that it plots, it'll like mess with if there's too many things open, and then it might like grab onto different figures and plot things on different figures. I didn't figure that out until like way later, but that was like a huge issue that I was having. This is cool. I love this little like animation right here of like the rotating little bar. Wow, it is compiling slow right now. It is having a rough time. It's probably because I'm streaming, but that's okay. I'm doing this for the people. Doing this for the people. Let's see what the deal is here. And we've still got a homie. I'm the homie. It's me. I'm watching. Wow. I'm the single person. It's all right. Let's do the Snapchat while this is compiling. Boom. youtube.com/me. Still compiling. Almost halfway done. Sweet. What do we want to talk about? I'm actually pretty hungry. If anybody knows how to analyze EEG data, they should hit me up. You should hit me up. I don't know what I'm doing. Well, we're getting there. We're getting there. I'm hungry and tired. What do you want to talk about? What do we want to talk about? We're just chilling. We're just chilling. Almost there. It's gonna take 11 days to save once we're done processing everything. Flame. Flame. Sick. Okay, so we are back in the studio. So now we have our movie file. So now what we want to do is stage some frames. So what happens is we pull up this window where our movie is in the center like top-ish, and then we can put frames, like specific frames from the movie, we can pull them out and put them at the bottom. So that's what we do here in the staging area. We'll pull out frame 50, we'll just call it 50, add it, 60, call it 60, add it, 70, call it 70, add it, and we'll just do 3 for now. And we'll toss in a custom frame. So the custom frames are actually really cool. You can either create a montage of like a bunch of individual frames and put them all into one frame so you can see a lot in a row, or you can create an average of a bunch of time points. So let's do the montage because it looks cool. So we can do the average too, but I already made Example montage. I already made them both. So actually, I think I made a new one that was better than that. I think it's real montage. We'll display it at 100. Our montage. Stage it. And then back here, real average. Display it at 150 and call it our average. If we want to play it, we need a movie selected first. So let's select our movie. Let's play it. Load in that file. What? The parameter name. String scalar. Ah. So this is trying to fix earlier. But when we call our when we call our GUI, we want to call it as settings. Well, when we get here, we need to parse out the settings. So this should just be settings, actually. Shouldn't it? I believe so. Character vector. Let's just add a parameter instead. I don't want to deal with that. So that'll be default settings. How's it gonna know what it is? Oh, it's up here. So that'll just be a parameter, so we won't need that. Settings. We'll do this. So we need to add our settings in as an optional parameter, but we're always going to be adding them in because we need to add a sample, right? And then we'll make our default settings. I guess like nothing. Well, it doesn't really matter. Like you have to add your settings in because you need a sample rate. Let's see what happens. Topo player. Cannot. First argument must be a string scalar or a character vector that can represent a field name. Add required. Oh, that's just like not what's there. Let me just restart it. Snag our movie file. I just changed how we get our sample rate because I wasn't collecting it the right way. It was right for a sample rate of 500 samples per second, but it didn't allow for any flexibility for people with a different sample rate. Settings previously appeared to be used as a function or command. It's used here as a name variable. Possible cause of this error is that you forgot to initialize a variable. Interesting. Where? When I call Topo Player? Settings. There is no settings. H object. Where do I call any settings? Handles. Dot settings. That's what it is. Let's go back to Topo Player. So that's going to be handles dot settings. I think. Let's close our Topo Studio. Reopen it. Let's grab our movie. I gotta just move this thing. Where did I put it? Okay. Another error. Settings previously appeared to be used as a function or command. Oh, come on. Not a variable. Comp5 Topo Player. 113. Settings might be used before it's defined. Okay. So we aren't, I see what's happening. We're not passing the settings in via, but we are, but we're not. Like, we're only doing it if we pass it in via an argument. So what we have to do actually, 113, oh, I see what's happening. So our settings are in here. So actually, we don't pass it in here. We go into Topo init, and let's keyboard on in here. And when we do that, we'll get here, and then we just initialize our settings here from the p variable that we pass in through that we pass in through. So this p, if we look at the structure of this, p dot results is going to have our settings in it. Results dot settings s rate. So this is going to have our sample rate. Now that should be good. And then we can chill. And now let's do it. Dopeness. Yes. And now we can see our movie. And it's rather large, so I'm just make it a little smaller. But that is so sick. That's so dope to me. So now we can see our EEG data as like a movie. So what we want now, everything works, good stuff. So what we want now is to be able to, okay, let's push our changes. Let's put that one file. Okay. That's all we need. We made it more flexible. Okay. So now we are solid with that. So we have our sample rate in one place. So now if you need to change your sample rate, you can just go into the Topo Studio init and change the sample rate here. That should change it for everything. Now, the bigger problem that we're having though is that if your sample rate is different and you want to create a montage or something, the montage only pulls from millisecond precision that exists. So let's say you have a frame that exists at 13.33333 milliseconds into your data. So you say here, you say, I want the 13th or millisecond 13 between that and millisecond 20. That's not going to work because it's going to go, there is nothing at millisecond 13. So we want to create something that says, but there's one at 13.33333, and we're going to make one from there anyway because we assume that's what you mean. Okay. So what we need to do, somewhere in here, I'm assuming right here. Actually, we can just keyboard in here. Just keyboard into the initialize. And I want to find wait. Oh. Oh, I just need to restart the studio. Okay, so what we want to do is we want to find all of the available time points for our thing. So we need to go, there's 1,000 milliseconds in a second, and we're collecting at 500 sample rate. So that's how we know how much time passes between each sample. So what we do is we multiply that number by the amount of samples that we have. So we have 400 samples, right? 400 times 2, which is 800. And then technically we subtract 1 because we start at time point 0. So time point, so we would do minus, and then we would say from 0 to whatever the answer was by 2s. And these are going to be all of our time points. So what that looks like in code, so yeah, you can see this all happens every 2 milliseconds because we're collecting at a 500 millisecond sample rate, which means that for every second, we're getting 500 samples. In other words, for every millisecond, we're getting 0.5 samples. In other words, every 2 seconds, we're getting 1 sample. So 2 milliseconds passes, we get a sample. 2 milliseconds passes, we get a sample. I don't know what that is. So we need to make a variable version of this. No, actually, we need to do that in actually, let's make a function. It's going to say get available time points, and if that's going to take in your sample rate and your data matrix, I guess, but it doesn't even matter. It's I guess it's just like your number of frames, and then it's going to output an array, which is just going to be like available points. Okay, so what we need to do is we'll use this to post studio background. This doesn't really matter. We'll play here. No, it'll be in a studio. So what this is going to do, it's going to take your sample rate, and it's going to go let's see, how's this going to work? There are available points. So first, we need to get the amount of time between each sample. So we'll call that our sample latency is going to be 1,000 milliseconds divided by your sample rate. Then you need to take your sample latency and multiply that by the number of frames that you have, and that's going to equal well, it's going to be total time, but then you need to fix it. So you need to subtract a frame because we zero it out. Right. Because we're going to start at 0. We're going to have a 0th time point. So total time is going to be your total time minus your sample latency. And then your available points is just going to be an array. And also points is going to be 0 through adjusted total time by your sample latency. So just to reiterate this, we're going to make the S rate 500, num frames is going to be 400. So our sample latency should be 2 because 1,000 divided by 500 is 2. And then our total time is going to be 800 because sample latency 2 times the number of frames 400 is going to be 800. And then we're going to subtract our sample latency from our total time because we're zeroing it out to 0 milliseconds as our starting point. Oh, it's 798. And then this is the tricky part. This is going to give us the array of available points from 0, our starting point, to our adjusted total time, which is this number. And we want to go to that by the amount of times between each frame. So our sample latency. So our available points should be 0 to 798 by 2s. And if we look at that, 798 is our max, and 0 is our min, and we go by 2s. Okay, so that's how we're going to get the amount or all of the available points in our thing. So let's say that our sample rate is 1,500, and our num frames is going to be, I don't know, like 600. Okay, so let's just plug in get available time points, that's rate, and num frames. And so this is going to be all of the these are going to be all of the points that are available to us when we're in milliseconds. So there will be a 0th frame, and there will be a frame at 0.66 milliseconds. There will be a frame at 1.33 milliseconds. There will be a frame at 2 milliseconds. So this is going to tell us exactly what we have to be able to extract. Without this, we have to know exactly when our time points are in order to extract them. I need to drink more wine. I need some music. But the last time I played music, like half of my stream got like banned or something. Okay. So now we have all our time points. I need food. I need food is what I need. Whatever. So when we play or when we get our montage, or when we get our average, we need to say something that says, hey, like, we didn't find a time point at that, but we found one at something else. So let's quit debugging here. Let's clear all this out. No. Studio. Whoa. And let's keyboard into our montage creator. Let's keyword right here. Total movie. We'll do it from 50 to 100. Create. It loads in the movie file. We keyboard in. We get our time window. Oh, dang it. We have to call this my settings. Actually. Wait, no way. Wait, for real? What happened to that? What? That's crazy. Whatever. No. No, actually not whatever. What happened? How did that change? What changed? I need my settings. What? Hmm. What? I don't know what happened. Settings group. I don't know what that is. What? We are so dumb. Oh, dude. Why? Okay, I'm gonna explain something really quickly. Very briefly. In all of our scripts that we write in our lab, we've been using a variable called settings. that variable exists in MATLAB. That's something we're overwriting. And now S, wow, we are so stupid. That's unreal. We are overwriting that variable. Okay, well, that is, I don't know why we do that. Because settings is like kind of a big deal. It's like kind of a lot that we're overwriting. So, I mean, I don't want to say that we can't do that anymore because that's just like, okay, so I'll show you. So if I change this to my settings, excuse me, we tried creating the frame. I need to eat some food. Good damn. Good damn. That doesn't make any sense. Oh, wait. This is montage. Okay, so this is actually handles.settings. Because we're passing in, wow, that's kind of cool. That's kind of interesting. We were passing in just like a MATLAB settings struct. So valid movie, that's not what I wanted to do. Now watch. We're passing in the right thing now, and so now if I keyboard in here and I do this, so my settings now, it's still that. I think I just need to like restart this whole thing. Let's see, 44 through 66. We'll call it We keyboard into her. Oh, see, now that's still interesting because I'm gonna keyboard here instead. Technically, we only really need the sample rate, but I don't know why it would be messing it up to passing the settings. So we just go into the montage. We do that there. I don't know. Let's try it. We'll keyboard into here. I mean, we've got our sample rate. It doesn't matter. We can always just pass in only the sample rate. That's the only thing that we need, but we might as well try it. I'd like to be able to pass in an entire settings struct, but I don't know why that wouldn't work. So we ended here, and then for some reason when we call my settings, we're getting a MATLAB. Oh, what is this? Why didn't this work before? MATLAB sucks, dude. Whatever. Let's just clear all this out. Oh, we did close it. Okay. Load in our movie file. Wait, before we do that, we don't want a keyboard into here. It's so strange that it's okay. Well, it's getting it now, so I think it was just like a weird, like just wasn't saving or something thing. But we've got it now, and so now we can get our time window. So that's the thing. So now we need to get our available points with that. So essentially the person is asking, give me everything that exists between this millisecond and this millisecond. So actually what we need to do first is we need to figure out if what they're asking us is available to them. So we have what, 44 and 66. So we need to get our available points right here. So we'll do get available time points with our settings S rate and yeah, see, actually, yeah. Wow. Okay, so they ask for a time window. And we need to get a time window between that. That just sounded so stupid. Wow, my brain is just not functioning right now. What is the second input to this? The number of frames? Okay, well, all that is this. So let's just move this dude on down. And we'll just do the length of the window. And so that should give us the yeah, I think that'll give us what we need. And we'll just call this our points. Oops. Oh, this is my settings now. Okay, so that did not give us what I wanted. Damn it. I wanted the total number of frames. So I wanted the length of anim. Yeah. I wanted all of the available points. So now I need to take the window and the end of the window. So the beginning and the end of the window, which is in frames. And if I convert it back to time, if I do frame to time window 1, that should give me 44. Oh, I need. Should give us 44. So what we want to do is check to see if our points that they this is hard. This is hard to this is hard math to code when you're drinking. There's a lot going on right now. My brain hurts. Should I just code like this for the rest of the time? What's up? What? What, you want some of this? That's what I thought. Anyway, actually, yeah, all we need to do is say, here's our window of our of the time frames that we want. We need to take those times, like time window 1. These are the original times that the GUI gave us. Time window 1 and time window 2. And we need to check if those are in our array. And if they're not, what are the closest things to them? And then we want to display in the command window that, like, hey, we found something that, like, you didn't ask for necessarily, but this is the closest thing. Should we just create another function that's that outputs? We want to be able to input like a time window and our points, and output like an adjusted time window, and in there display to the command window that, hey, like like what I said, like we didn't find what you were looking for, but this is like the closest thing that we have. So let's do that. Check time points. That's going to take in points and time window. And it's going to output corrected points. So our points will be what we get from our get available time points function. Which is that. So we have our window and our points, but we want our time window still in milliseconds. We don't want to convert it to time frames just yet, because we don't know if the milliseconds exists as points as our frames. So in other words, this points array contains all elements that exist as a frame. So all of these have a correlational time frame. So like there's one at 772 milliseconds, but there's not one at 773 milliseconds. Basically is what that's saying. So what we want to do is we want to find what's available, check time points. So our time window, we'll just do start time window 1, and our end time window 2. So this would be so much easier in Python. So much easier. Just say, is it inside there? But we are gonna have to figure out how to loop through this thing and basically check. Oh, that is Python. We want MATLAB. Oh, that's super neat, but like way, way more complicated than it needs to be. Just like stupid more complicated. Okay, watch this. This is actually about to be just like so stupid. So just so stupidly complicated. Okay, so we have our matrix, which is points, or our array, which is points, and we have our time windows. So basically, we need to find. Wow. Okay. This will be our inval and our. Okay. And we're going to do the minimum absolute value of our points minus the start. So what this is going to do is, well, we have points in time window. Okay, cool. So we'll get our start and we'll get our end. What this is going to do is it's going to say for all the values of points, subtract the value of the start and grab the absolute value of that and find the minimum absolute value of whatever all of those are. And then get the index of it, which is 23. And then go back into your points and do start value is going to be points min index. What? That doesn't make any sense. What? Come on. I mean, there is one. Oh. I'm so stupid. Oh my god. I'm so dumb. I'm just so dumb. Of course there's gonna be one in there because we're asking it to look inside of itself and be like, is there something that's close to you? And it's like, yeah, it's the one you're asking for. And you're just like, yeah, all right. Yeah, well, then how are we doing this? What is the deal? Oh, I get it. Yes, we found it because we knew that 44 was in there. We knew that 44 was inside of that matrix. And we know that 66 is in there too because it just goes by twos. So we knew that. Also, we don't need this min val. And then we just do the same thing. And then that, but then we want to display. If time window 1 is not equal to start val, and we basically want to display starting value is not found as a frame using start val instead. Okay. Oh!
Dude, walking in. I smell burnt. Look, yeah, I'm like, well, did he leave anything in this question? And I was like, well, there's your last potato. I'm like, yep, okay, that's out. Like, oh, dude, that thing is destroyed. Cut it open. It might be, nope. Nope, I put that in there at like 2 p.m. Try it, though. Cut it. See what's that. Oh, dude, this thing is a freaking stone. Yeah, dude, smell that. Yeah, that's what it smells. Yeah, yeah. Damn it! I was so excited about this. Pumpkin potato. Yeah. I've been drinking heavy and streaming some coding. I saw your snap. Yeah, dude, I'm hyped about it, but I'm getting hungry now, and I have 0 viewers, so. Yeah, the viewers are giving me a break today. Instead of my massive following of 6 people, got 0. I'll allow it. You're just grinding hard right now? Right now, shit that I should do tonight, so I don't forget. I just got back from guitar.
You trying to grind sesh?
In about an hour, I'm gonna head out and then be back.
Where you headed?
Yeah, lady.
I'm gonna turn off my stream. I love the people, but it's time for me to eat some food. So, yeah.